Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This is Yunus Khan and I'm here with a new topic of biology from class 2nd year. So today we are going to talk about the lung volumes and lung capacities. First of all, we have to talk about the difference between the lung volume and capacities. Lung volume or pulmonary or respiratory volume, it is the amount of air, it is that volume or amount of air associated with different phases of respiratory cycle. For example, we inhale the air, then we exhale that air. One breath is completed and one respiratory cycle is completed. During this respiratory cycle, different kind of changes takes place in our body, in our lungs, etc. So that amount of air or that volume which is associated with these different, for example, with inspiration phase or expiration phase, so with different expiratory phases of the respiratory cycle, the amount of air or volume which is concerned or which is associated is called as the lung volume or the pulmonary volume. On the other hand, the lung capacity, or it may be also called as the pulmonary capacity. What does it mean? This is a sum of the two or more than two volumes. When two or more than two lung volumes are sum up, so their calculation results in the lung capacities. This is what? This is the sum of two or more volume, means lung volume, the pulmonary volume or respiratory volumes. It is what? It is basically a calculated amount. This is the actual volume which is measured once, and this is the calculated amount which is calculated by the summing up of the lung volumes or respiratory volumes. So we can measure the lung volumes or pulmonary volume, but we can calculate this one. This one can be calculated. It is a simple algebra, and the lung volumes or pulmonary volumes can be measured. It cannot be calculated, it can be measured. So how can we measure it? So it can be measured with the help of a process which is called as spirometry. Spirometry. That is a process with the help of which we calculate different kind of pulmonary volumes. And the device which is used here to calculate it, that is called as spirometer. If we talk about the device that calculates the lung volumes, that is called as spirometer. So spirometer is a device with the help of which we can measure the lung volumes, and the process of measuring the lung volumes is called as spirometry. That is called as spirometry. So therefore we can say that lung volumes can be measured. On the other hand, lung capacities, that can be calculated by adding two or more than two lung volumes. So this is about the difference between two, the main concept about the lung or pulmonary volume and about the lungs capacity or pulmonary capacities. Okay, further talking about the lung volumes, there are four main kind of the lung volumes. Which can be shown here with the help of this diagram. Here we have drawn the y-axis shows the volume in ml, 1000 ml, 2000 ml, 3000, 4000, 5000 and 6000 ml, and the x-axis shows the time. It shows the time. Okay, so the first volume, which is normal volume during the normal breathing in and out of the air, that volume, for example, we are normally taking in and taking out the air. For example, this one. So this is called as tidal volume. This is called tidal volume, and it is said that during this normal breathing we take in and out about 500 ml. Half a liter we take in and take out during normal breathing. If there is a forced inspiration or expiration, so the amount of the air inhaled and exhaled is increased. So during normal breathing, the amount of air taken in and taken out, that is about 500 ml. So for example, here is we take that normal amount with the help of this graph. So this is called as tidal air, tidal volume. The first one that is called as tidal volume, tidal. So if we want to talk about that first normal volume, that is called as tidal. Tide means waves, like waves. So when we inhale and exhale air, waves are formed. Or if we wanna represent it here with the help of a diagram or a graph, so again here also some tide like graphical structures are found. So it is what this is. For example, the inspiration, the air inspired. So this is the air inspired. For example, we have taken a start from 2,300 ml till 2,800 ml. So this 500 ml amount is taken in. This is inspiration, the breathing in of the air. Okay, now at the same time, meanwhile, we will exhale that amount of air, means 500 ml of the air will be exhaled. Then the graph will come down. So in this way, 500 ml is taken in and taken out, taken in and taken out. So in this way, a tide, a diagram having tides, that is drawn over here. So therefore, this is called as tidal volume. This is the first volume which have been shown here, and this is called as tidal volume. And this is that amount of air which is taken in and out during normal breathing. During normal breathing. So when we do normal breathing, at that time normal amount means 500 ml of air is taken in and out. For example, sometimes if we take more than that normal breathing, if we take amount of air more than that of normal breathing, so at that time what would happen? For example, a large amount of air is taken in, so this extra amount of air is reserved. That is reserved during inspiration. That is reserved during inspiration. So for example, this is the normal breathing of inspiration again, and if we take more amount than that, then what would happen? Then this is for example a graph. So what would happen here? This amount will go up, means so much amount has been taken by you. It is said that about 3,000 ml of air is taken in other than that tidal air. So this amount of air is extra amount. This is that extra amount of air which has been taken in during a deep breath. During a deep breath. So during a deep breath, this extra amount of air is a reserve volume of the air during inspiration. During inspiration, and a reserved volume of air is inhaled. So therefore, this portion, this amount of air is called as inspiratory reserve volume. This is called as inspiratory reserve volume. So this is the second. This is the second volume, which is called as inspiratory reserve volume. This is the inspiratory reserve volume. So the second reserve volume is that which is the amount of air taken in extra to that of the tidal volume during a deep breath in. Okay, so that amount of air which has been taken in extra to that of tidal amount, same amount of the air will be exhaled during expiration now. So this means same amount of the air will be exhaled now. Same amount of the air is exhaled. Along with that tidal air must also be exhaled. That must also be exhaled. So this total amount of the air which has been taken in, that has been released here during expiration. Sometimes what happens, the tidal air or volume and the inspiratory reserve volume. These two volumes have been discussed. Another, sometimes we do what? Sometimes we exhale more amount than the tidal air. For example, we take in, so we release more amount of air during expiration. So if that amount of air is shown over here with the help of this graph, so this means that the amount of air which is released extra to that of the tidal volume is shown here, and this is what? This is another reserve volume which has been released over here now. This means this is another reserve volume which has been released during expiration. Therefore, this amount of air which is expired as a reserve, that is called as expiratory reserve volume. So this is the third volume, which is called as expiratory reserve volume. Expiratory reserve volume. So that amount of air which has been expired during this part of the breathing, that must be taken in first. So when we take in the air again, at that time what would happen? This amount of air will be taken in first. This must be taken in first, and then after that the tidal air is inhaled, and in this way the tidal inspiration takes place normally. So this is the normal inspiration, which is about 500 ml. Then inspiratory volume, which is more extra volume, that is inhaled during a deep breath. And similarly, that volume which is exhaled extra to that tidal volume during a forced expiration or a forced exhalation. Similarly, if we look at that, for example, we exhale that extra amount of air from our lungs. What happens? A little amount of air still exists there, which cannot be removed. If you remove the total amount of the air from your lungs, what would happen? The lungs will be collapsed. The lungs will be collapsed. So the shape of the lungs, which is maintained, that is due to that small amount of air which exists, which remains inside the lungs forever, that cannot be removed. And this is that amount of air. For example, we take this one. So this is that amount of air which is remained inside your lungs forever, that cannot be removed. If you remove this amount of air, so what would happen? As a result, your lungs will be collapsed, and that will be out of function then. So the lungs maintains a shape, and that is the shape which is maintained by some of the amount of air which is inside your lungs, and that amount of air which is inside your lung, that is another volume, and that is the fourth one. So the fourth volume is a residual volume. This is a residual amount of air which resides inside your lungs forever. So this is called as residual. This is called as residual volume. This is called as residual volume. So these are the four volumes. One is that normal, the tidal. Another one, that is the extra amount which is inspired during inspiration as a reserve, is called inspiratory reserve volume. Then that amount of air which is exhaled more than that of the tidal volume is called as expiratory reserve volume, and that amount of air which remains inside your lungs after this expiratory reserve volume being exhaled, so that amount of air which remains inside your lungs is called as residual volume, that resides inside your lungs forever, that cannot be removed, never. Okay, so this is about what another thing which have to be kept in mind: inspiratory reserve volume, expiratory reserve volume, and tidal volume. These are very easy to be measured. These are very easy to be measured, but the residual volume stays inside your lungs forever, so that is very difficult to be measured. there are certain means and ways through which we measure this amount of volume or air inside your lungs, but this is very difficult to measure it. Anyhow, it is said that the amount of the air which is taken as a tidal, that is 500 ml. So 500 ml volume of air is taken as tidal. The amount of air which is taken in during inspiratory reserve volume inhalation or air inspiration, it is thought that this is about 3000 ml, means 3 liter. 3 liter amount of volume is taken in during inspiration as a inspiratory reserve volume. Similarly, the expiratory reserve volume is said to be 1100 ml, means 1.1 liter. 1100 ml is taken in as expiratory reserve volume, and the amount which is left behind inside your lungs forever, that is said to be 1200 ml, means this is 1.1 liter, this is 1.2 liter, this is 1.2 liter, and the tidal volume, that is what, that is 0.5 liter, means half a liter. So this is about the different kind of volumes which have been discussed over here, The second thing, that is lung capacity. So what is the lung capacity? The lung capacities are the calculations. This is the amount which can be calculated by adding or summing up 2 or more volumes or lung volumes. So there are different kind of lung capacities over here. The tidal volume and inspiratory reserve volume. This is the amount of air which is taken in. This is the amount of air which is taken in during inspiration, the tidal and the inspiratory reserve volume. This is the amount of air which is taken in during the inspiration. So when tidal volume and inspiratory reserve volume, they are sum up, these two are added to each other to form inspiratory capacity. So the tidal volume, we have discussed that it is about 500 ml plus the inspiratory reserve volume, that is 3000 ml, that is 3000 ml. So this 3000 plus 500, it becomes the inspiratory capacity becomes 3500 ml. 3500 ml volume is that of the inspiratory capacity. Similarly, the functional residual capacity, it is that residual capacity, which is calculated by summing up of expiratory reserve volume and the residual volume. This is that amount of volume which can be taken in after the normal breathing inside your lungs. So this means if you do normal breathing, the residual volume plus expiratory volume, both of them resides inside your lungs forever. If you exhale more amount, then this expiratory amount of reserve volume can be released from your lungs, but this must be reside inside your lungs forever. So this means that this is the residual volume, along with which this expiratory volume must also be present there during normal breathing. During normal breathing, this is the whole amount of volume which resides inside your lungs. But here what happens? Out of this whole amount of air, the expiratory reserve volume, means a part of this volume can be brought under function, which can be used. For example, if we try to release some amount of the reserve volume inside your lungs, this expiratory reserve volume can be released. Therefore, this amount plus this amount, that is called as functional residual volume. So the functional residual volume is a calculated result of the expiratory reserve volume as well as the residual volume. So the expiratory reserve volume, I have told you that this is an amount of about 1100 ml, and the residual volume is 1200, that is 1200 ml. So when these two are added up, what happens as a result, the total functional residual volume is 2300 ml. This means during normal breathing 2300 ml amount of volume resides inside your lungs, out of which this 1100 can be removed, and this 1200 resides inside your lungs forever. So this is the amount which resides inside your lungs during normal breathing, out of which this part of the residual volume can be removed. So therefore it is called as functional residual capacity. Next is the vital capacity. Vital capacity is that capacity in which we do what? We take the tidal, inspiratory and the expiratory reserve volume. That is the vital capacity of the lungs. So tidal volume, I think it must be clear to you, that is what? 500 ml. That is 500 ml. Inspiratory reserve volume is equal to 3000 ml, and expiratory reserve volume, that is about 1100 ml. So calculating this, 3000, 3500, 36, 4600. So the vital capacity is about 4600 ml. That is 4600 ml. And the last capacity is the total lung capacity. Total lung capacity is the whole amount of air taken in and out, and that which is called as residual volume. So this is inspiratory reserve volume, then the expiratory reserve volume, then the tidal volume, and the residual volume. This one, this one, this one, and this one. All of them, when they are summed up, so they form the total lung capacity. So the inspiratory reserve volume, this is 3000 ml. Expiratory reserve volume, that is 1100 ml. Similarly, residual volume is 1200 ml, and the tidal volume is 500 ml. So this become equal to 3000, 31, 41, 43, 53, and plus 5, that is 5800 ml volume. So the total lung capacity is about 5800 ml or 6000 ml, means 6 liter. So the lung has a total capacity of 6 liter roundabout. This is about the lung capacities and lung volume. One thing which have to be discussed over here, and that is dead space. Dead space is another thing which have to be discussed. Dead space and dead space air. So other than the lung, these are the volumes which have been discussed regarding or with respect to the lungs. Other than that, some of the air also resides and also present inside your bronchi, trachea, and the larynx. So what happens here? Other than your lungs, rest of the respiratory pathways which contains some amount of air or space, which is called as dead space. Dead space is that space which is present in your respiratory pathways other than the lungs. Respiratory pathways other than the lungs means, for example, in larynx, trachea, bronchi, and bronchi. So this is called as the dead space. This is the space which cannot be utilized during the exchange of gases. Here, during this space, no exchange of gases takes place. So this is what? This is the dead space, and the amount of air which is present here in the dead space is called as dead space air. So this is about the whole story of the lung capacities and the lung volumes, lung capacities and the lung volume which have been discussed over here. Once again, if you look at the summary, so lung volumes are of 4 kinds: tidal, inspiratory, expiratory, and the residual volume. And these are the 4 kind of capacities: inspiratory capacity, functional residual capacity, the vital capacity, and total lung capacity. Other than the lungs, rest of the parts of the respiratory tract contain a space which is called as dead space, and the air which is present there, that is called as dead space air. The dead space air can never be used during exchange of oxygen and carbon dioxide. When that comes in, that cannot be reached to the lungs, and during exhalation that is removed along with that. So this is about the whole story. If you people have any kind of question, ask me in comments. I will try my best to answer those questions. Till next video, thank you very much. Allah Hafiz.